Hello everyone. Welcome to today's session, Digital Infrastructure, Mastering BIM and OpenBIM. Thank you for joining us. In this exclusive masterclass, you will discover how next-generation digital tools, open standards, and advanced workflows are transforming infrastructure design and delivery. My name is Thaisa Figueroa. I'm Institutional Relations and Program Manager here at ZIGURAT, and I'm thrilled to be your host today. And if you are new to ZIGURAT, here's a quickly introduction. We are online education with over 20 years of experience in e-learning. Our programs cover architecture, engineering, and tech management, helping professionals worldwide boost their careers. And we are proud of our global community with more than 20,000 students from over 120 countries. So at ZIGURAT, we believe in unlimited possibilities, unlimited knowledge, future, success, leadership, and imagination. And that spirit of limitless growth starts right here with all of you. So before we dive in, let's try to make this session a little bit interactive. Please share with us in the chat, where are you joining us from today? I'm here from Barcelona. Chakad is in Stockholm. Dmitrii, Manuel is with me here in Barcelona. So let's see, where are you? And let's keep the energy high and stay connected throughout the session. I can see people here from Saudi Arabia, Italy, Cape Town, oh, Brazil also. Yeah, I'm Brazilian. Nice people. Nice to see this. You are connected with us. Welcome. Well, nice. So today's masterclass is directly linked to our Masters in Global BIM Management in Civil Engineering and GIS. So this program equips professionals to collaborate globally, working on real-world civil engineering projects while mastering the three key pillars. Technology, process, and people. Now, I'd like to introduce my colleague, Manuela Barbero, International Admissions Team Manager at ZIGURAT, and she will share why this program can be a game changer in your career. So Manuela, thank you, and it's over to you.
Thank you, Taisha, for the introduction. So good evening and good afternoon, everyone. I'm the International Admission Team Manager in ZIGURAT, and we are managing all the admission for all the students in all the master. Today we're talking about the Master in BIM in Civil Engineering and GIS. It's a program that started twice per year in ZIGURAT. Usually we started in May and November. So in this moment, we are open the registration for the November edition intake. Is a program with in ZIGURAT we have an online methodology with the synchronous methodology, which means that during the year you will be in touch with the student and the lecturer in live twice a week. It's a master with many important accreditations starting from University of Barcelona, but then the master has been accredited also by Building Transformation and CIOB, that is one of the most important in the UK. We just get the accreditation after years of trying to get this kind of accreditation for the CIOB. We are the only school in Spain that get it. If we go a little bit more in the master program, I will show you more or less just briefly what they're going to learn during the year. If you can go to the next slide. The program is divided in 5 blocks. During the master, we talk about, of course, Global BIM Management. And the first part is where we started to be involved in all the part of management. When I talk about management, of course, I talk about protocol standard, ISO, WRF, documentation. We work in OpenBIM in ZIGURAT. So in this part, we also explore the part of OpenBIM and the IFC platform. And then in the second part of the program, we are doing integration of BIM and GIS. And the part of integration of BIM in GIS is very important because, of course, we need many information before the program, so the project start. Here we are locating the special data. We are gonna to get many information regarding existing utility or, for example, DTM. But then in the third block is where really we start to work on the project. And then our guests today, they are talking definitely better about it. But briefly, the project is an hypothetical road project according to 5 aspects: topography, geometry, earthquake, terrain, and bridge. What is really interesting, and then we will check later in the benefit of this master, that is in a point of the project, you can add other specialization. The fourth part of the master, we are talking about VDC, 4D, and 5D. So we are talking about visual design construction. Here we are integrated to the 3 dimension, the dimension of the time and the dimension of the cost. And in this part, we start to do virtual representation of the project, and then, of course, later we talk better about the benefit. Last part of the master, we talk about the part of asset management. So we're talking about operation and maintenance. So we are gonna to check all the benefit of the operation maintenance regarding the road project and the specialization that you are choosing. If you go to the next slide, we have just an idea of the benefit that you can get in joining this master program. ZIGURAT is ranked as one of the top schools in the world in BIM. As Taisha told before, we started 24 years ago. In this program, we talk about BIM for Civil Engineering and GIS. We talk about cutting edge technology and knowledge because we apply the new methodologies in the part of infrastructure and GIS. We focus on data management, interoperability, and digital transformation. We talk about the practical and learning because we work on a real project and simulation. And this is your master final project that we will develop progressively through the entire program. And then we talk about the part of flexibility and support. The program is structure for professional profile, which means that you can study and work at the same time. You have online live online methodology, access to advanced campus such as a Canvas platform, mentoring, and continuous academic and career support. But you will be involved in a global network. So become a part of ZIGURAT alumni. You will be part of community of more than 20,000 professionals from different 120 countries in the world. You have access to local hubs, student week, and executive networking. If you go in the next slide, I talk about specialization option. Specialization option is what I was advancing before. In a part of the project, you can decide to add to your road project or a road or the part of water supply and sanitary receiver. So you can choose between different sectors for deeper expertise. It's career-oriented training because the program is designed to prepare you for roles such as BIM infrastructure manager, GIS consultant, head of technology, and much more. And in this master program, you will have a faculty of experts because you can learn from the top professional consultant with international experience in infrastructural and digital transformation knowledge from different countries in the world. We offer a personalized tutoring and support because during the year you will get a support from a personal student assistant and an academic coordination. Is a program that will give you a dual master degree because you can earn a double degree accredited by University of Barcelona and ZIGURAT recognized worldwide. But meanwhile, you will get official recognition from Autodesk and Bentley and validated technical proficiency while you use BIM tools. And as I mentioned before, now also from CIOB. Here are just an idea in what you're going to learn during the master program. Now we give voice to two alumni that just finished the master, and they will introduce themselves because one of the two student alumni has been one of the best student, but both was part of the best project that we developed in the last edition. So congratulations our alumni. I give them now the chance to speak better about the project. And of course, if you like, with pleasure, we will be here to provide you with more information. Thank you very much to everyone.
Thank you, Manuela. Thank you so much. I would like to present Chakad and talk a little, Chakad and Dmitrii before. Let me pass the presentation here. So we are super proud to welcome two outstanding professionals who played a key role in the team behind the Final Master Project, awarded the Best Final Master Project in the May 2024 edition of our Masters in Global BIM Management in Civil Engineering and GIS. So now it's my great pleasure to introduce our guest speakers. So Dmitrii, who is BIM Manager, Parametric Bridge Engineer, alumni ZIGURAT, and also ambassador. Sorry, Dmitrii, I forgot to put here. And Chakad, who is land surveyor, BIM and construction management expert, and also ZIGURAT alumni. So a quickly reminder to our audience. If you have any questions during the session, please drop them in the chat and we will address them at the end of the session, okay? During the Q&A at the end. So Dmitrii, Chakad, welcome. It's a true pleasure to have you here with us. And the stage is yours now. Thank you. Thank you so much.
Hello, everyone. Thank you for the introduction. And shall I share my screen?
Perfect.
Okay.
Yes.
Okay. Good morning, good evening, good afternoon, and welcome to today's Open Masterclass. Thanks to ZIGURAT for this kind innovation. We're excited to present digital infrastructure, master in BIM and OpenBIM, an overview of BIM workflow integration across infrastructure projects, with insights from our final master project. So let's dive in. I'm Dmitrii Korchemnyi, BIM Manager at Institut Giprostroymost and a Parametric Bridge Engineer. I focus on detailing design processes and implementing BIM uses. With my BIM expertise, I deliver optimized solutions for infrastructure projects. I hold degrees in bridge engineering from AD and BIM specialization from ZIGURAT, where I also serve as an official ambassador representing the institute in Russia. I'm passionate about driving innovation and automation across disciplines, and currently I'm actively seeking a topic for my future PhD research.
Hi, everyone. My name is Chakad Bozorgmehr, and I work as an office surveyor. My focus is on developing more automated process to document project status and quantities, while ensuring a more integrated and seamless flow of information through construction. I'm passionate about leveraging technology to improve accuracy, efficiency, and collaboration across team projects. Let's go through an overview. We will start with BIM management and how it connects with GIS integration. Then we will move through the project lifecycle from concept design and design development to coordination and innovation that improves efficiency. Finally, we would look at the construction phase and how everything ties to asset management. Together, these steps represent the full journey of a project. Project charter. Project charter is the cornerstone of the project and the base point to start. It defines the title, objective, and the scope, and it brings together the high-level requirements that will guide further development. The charter also identifies the key stakeholders, consider risk, assumptions, and constraints, and most importantly, it delegates the necessary authority to initiate the project. By setting this foundation early, the Charter ensures clarity, alignment, and shared understanding before moving forward. Practice for BIM team. As BIM is about sharing information and managing integration, the team also needs a strong understanding of how to share and integrate efficiently. It's not just about the tools for the models, but about the people behind them. A successful BIM team builds trust, communicates openly, and takes responsibility for their role while respecting others. When everyone contributes and listens, collaboration becomes natural. Problems are solved faster, and the flow of information stays clear and reliable. This mindset is what turns BIM from a technical process into a culture of teamwork, accountability, and continuous improvement. CDE, Common Data Environment. In a common data environment, several features ensures that information is well structured, traceable, and easy to use across the project lifecycle. Here are some features of CDE. The first, naming convention configuration. This feature enforces discipline by not allowing documents with incorrect names to be uploaded. It guarantees consistency and makes sure files can always be found and referenced correctly. Second, user-defined metadata and labeling. By assigning attributes like type, discipline, status, etc., the platform makes it simple to filter, navigate, and quickly find the right document among thousands. Next, collection features. Collections are immutable binders that groups deliverables together, allowing us to deliver complete and traceable packages while preserving the integrity of their content. Fourth feature is approval request workflow. This ensures that the documents move through well-defined status from draft to review and finalized, so everyone is clear on what stage a deliverable is at and who is responsible for approving it. Finally, the issue feature strengthens the coordination. It allows us to flag problems directly in the CDE, assigning them to the right person, and track them until resolution, improving collaboration and closing feedback loops. These are only some of the main features of a CDE, but together they already provide a greater control, traceability, and efficiency, helping the team deliver with confidence and better coordination. Risk management. Risk management in BIM project follows a full life cycle of identifying, analyzing, responding, and constantly monitoring risk. The real value here is not just documenting the risk, but also foreseeing how we should respond to them before they impact the project. As BIM methodologies and digital solutions continue to evolve rapidly, our risk management approach must adapt. This means shifting our focus not only on minimizing threats, but also on recognizing and maximizing the opportunities. Opportunities such as automation tools or better data integration, which can significantly enhance project outcome if we act on them early. In risk management, opportunities are handled with the same importance as threat, but responses focuses on creating positive outcome. We can exploit an opportunity to ensure it will happen, enhance it to increase its benefit, share it with a partner to minimize the value, or accept it when it requires no action. Through tools like risk register, integrated base reviews, and continuous monitoring, we create a proactive system which ensures that risks are tracked, responses are prioritized, and adjustments are made in real time. In short, BIM risk management is not only about protecting the project from failure, but also about positioning the team to capture the opportunities that lead to greater success.
Our project follows a clear BIM framework. We created key documents at every stage to support coordination and smooth delivery. At the top, at the strategic level, we begin with the ER. These documents set the BIM goals, software standards, and data needs for the whole project. It creates a strong base for digital collaboration. Next, in the middle, at the tactical level, we use the BIM execution plan. This plan defines who does what, how we communicate, and which BIM workflows we follow. It also lists possible risks and how to manage them. This helps all team members work together in the same way. And finally, at the operation level, we prepare production manuals, progress reports, and quality checklists. These tools make sure we apply BIM correctly and consistently across the project. So this structured process improves coordination, reduces mistakes, and help us deliver the project more efficiently from start to finish. BEP, BIM processes. BEP, BIM execution plan, is the main document in our project. It brings all team members together from start by clearly explaining roles, tasks, workflows, and possible risks. This shared understanding helps make the project run more smoothly and saves time and money for the clients. For our project, we created a BEP that includes all BIM users. We created BPM diagrams for each BIM use, a clear visual diagrams that shows the workflow step by step. This method supports teamwork and helps us manage risk throughout the project. GIS integration, collection data from GIS sources. We use top 3 GIS data sources to support accurate infrastructure planning. These datasets are reliable, up-to-date, and free, helping us make better decisions. For our UK project, we used detailed maps from the Coordinates Survey Data Hub and the UK Government Data Portal. OpenStreetMap provides key vector data. For global use, I strongly recommend satellite images from Copernicus and terrain models like FabDem, NASERS, SRTM, and ESTER. Together, these sources helped us create accurate maps. Comparing data collection. From my experience generating DTMs, as shown on the slides, comparing FabDem to real land surveys reveals key accuracy points. In urban areas without large forested zones, the average difference is 0.5 to 1.5 meters. In forested areas, trees not fully removed show an average offset of 3 meters, with a maximum difference up to 8 meters. Another great feature is accessing online parameters via WMS, like those from Environmental Data Government Portal, directly in QGIS. This enhances your ability to integrate real-time data into projects, supporting informed decisions. Multi-criteria analysis, or MCA, take a look at this beautiful set of maps created by our team for the first MCA site analysis. Our goal was to find the best route for the road using MCA with Delphi method to get expert agreements. We use spatial data and modern GIS tools to plan carefully, reduce risks, support a sustainable and cost-effective design. Next, we brought these maps into InfraWorks, combining terrain, buildings, and environmental data into one base model. And this helps us visualize the project better and supports faster, more accurate decisions. WebJS, in my view, one technology that really improves teamwork is WebJS. On these slides, you can see an example using Next.js. WebJS lets several people access, view, and even edit maps and data online at the same time. This makes it much easier to work together, even if the team is in different places. The main benefits are better data sharing, secure access for all project stakeholders, and real-time updates that helped with faster decision making. It also works with tools like QGIS, ArcGIS, and making it a strong support for planning and designing projects. Road option generation using AI. As a part for our project, we designed a road to improve connectivity between two locations, Falmer and Rodmel. We used software roads with AI alignment optimization, which automatically generates road alignments based on terrain, engineering constraints, and environmental zones. Input data includes BTM, land use layers, restriction zones, and all collected from JS sources. This approach helped us reduce earthworks, lower the impact on the environment, and make the road design more cost-effective to build. Road option generation using AI. It's case study InfraSpace example. I want to share a new exciting tool that we didn't use in our projects, but I believe it has great potential for future design. It's called InfraSpace. This platform using AI to generate many road alignment options based on cost, design rules, and JS data. You can upload alignments, see 3D views right away, and check key results on dashboards. It helps you choose the best option for cost and environment. It works online, supports teamwork, and offers smart features like earthwork estimates, automatic 3D visuals, or optimization. After running the AI-assisted road alignment design, we generate 5 alternative road options for our projects. To evaluate this, we developed MC Report Part 2 using a structured framework with key criteria. The radar diagrams you see here helped us visualize and compare the performance of each option. The analysis clearly shows that option 1 is the best choice overall, the direct route with low cost. The project is divided into 3 phases, and our evaluation focused specifically on phase 2, highlighted on the map. Proposal 1 includes an overpass to cross the ravine, reducing earthworks and preserving the natural landscape. The road follows the terrain closely, minimizing impacts on sensitive areas. We also prepared a cost estimate, and after reviewing the data, Proposal 1 proved to be the most cost-effective. We built the overpass in Tekla structures with Rhino and Grasshopper driving a parametric model. It's a pressurized concrete bridge using the balanced cantilevered methods. We have 2 piers, 2 abutments, and a variable depth to tell box deck. Inside the deck are anchorage blocks, ducts, communication lines, and lighting. Each pier and abutment has an access door, communication lines, and includes slope protection and approach slabs. The complex geometry is fully controlled in Grasshopper. Every key dimension is a parameter: span length, box width, web, slab thickness, and abutment offsets. And the main, when we change one value, the whole model updates. This keeps geometry, quantities, and drawing in sync. So on the BIM sites, every object has a stable ID at the required property sets. We assigned unique class classification, and BSDD, and we fill the key concrete data. On one of the scripts is an assigning attribute script. A Grasshopper script inside Tekla after assigns these attributes. Pull data. For data exchange, we export a clean IFC4x3 element map to the right entities. For example, IFC bridge part, and other specific entities for deck, piers, and abutments. So this end-to-end setup delivers consistent geometry and reliable data for digital delivery.
Road design. In road design, efficiency and accuracy are critical, and this is where sub-assembly composer and parametric design brings real value. By creating custom parametric components, we can build data-rich model that automatically adapt to the changes. This allows repetitive design elements to be automated, and modification such as changing width lane or slopes or material can be applied instantly across the entire project. The result is a much faster and more consistent and more efficient design process while supporting a standardization across the project. In addition, tools like Dynamo extend automation even further. Dynamo enables us to script workflow that automatically assign attributes to Civil 3D objects, such as materials, classifications, or asset information. Instead of manually editing hundreds of elements, attributes are applied in a bulk base defined rules. This not only saves time, but also reduces human errors and ensures data is ready for analysis and integration. Drainage. In drainage design, parametric modeling in Civil 3D allows us to create data-rich components like pipes, manholes, galleys, and inspection chambers that automatically adapt to the design changes. This means that when we adjust a slope, diameter, or alignments, the entire network updates instantly, eliminating repetitive manual work and ensuring consistency across the design. Alongside this, the Analyze Gravity Network tool brings powerful simulation capabilities into the workflow. It enables automatic pipe sizing and optimization, checks for performance issues like surcharging, and provides detailed hydraulic results such as flow, velocity, and cover performance. With these results, engineers can quickly test multiple scenarios, refine the design, and ensure compliance with the standards. Together, parametric design and network analysis make the process much faster and more reliable. They allow rapid iteration, improve accuracy, better visualization, and seamless integration with other disciplines, ultimately saving both time and cost while delivering higher quality design. Underpass. In underpass design, we design underpass and culverts. Underpass and culvert were designed in Civil 3D using IFC 4.3 extension. All elements were carefully modeled with correct IFC entities assignments, along with BSDD attributes and COBie parameters to support operation stage. This approach ensures high quality and organization, full BIM approach, compatibility, and readiness for future asset management. Tramway. For funicular tramway design, we were inspired by Peak Tram in Hong Kong. The design includes key elements such as cable, rail track, and slab pavement, carefully modeled to meet funicular system requirements. We assign BSDD attributes and COBie parameters fully synchronized with UK standards to support future operation and ensure high-quality digital assets for long-term maintenance. Coordination. Effective coordination is one of the biggest advantages of combining platforms like Navisworks with common data environments such as Catenda Hub. Navisworks allows us to run powerful clash detection, identifying conflicts between disciplines early in the design phase, such as drainage colliding with a structure or a utility. Such clash can then be documented, tracked, and assigned directly to an issue. By integrating CDE, these issues don't just stay in the model, they become a part of a structured workflow. Catenda Hub ensures that every issue is logged, assigned to a responsible team, given a status, and monitored until it resolved. This creates full traceability, reduce communication gaps, and avoid costly rework during construction. This coordination routine can be carried in many aspects, including geometry coordination, data/information coordination, interdisciplinary coordination, constructability and safety coordination, and etc. Together, Navisworks and CDE like Catenda Hub create a seamless loop, detect issues, assign them as an issue, and solve them within the project data environment. The result is a smoother collaboration, fewer errors, and more efficient project delivery.
IDS checker. We check our IFC models against the project rules using IDS. First, we turn the client's ER into machine reliable IDS rules in IDS Maker. We set simple exact checks, which entities, which properties and data types, and the allowed formats. Next, we export the IDS file. In Blender BIM Bonsai plugin, we load the IFC, load the IDS, and run validation. Bonsai creates an HTML report with pass or fail for each rule and each element by global ID, and it shows any missing or wrong values. This workflow follows ISO and the lowing. It gives us consistent, complete data, reduces rework, and makes data exchange between clients, models, and software reliable. IFC to Excel. Another helpful tool is the TDS IFC converter. It's free, simple, and works fully offline. It converts IFC files IFC2x3 to IFC4x3 into Excel and DAY formats. This workflow is easy. Select your IFC, choose Excel or DAY format, and click Convert. The Excel file lists every element as a row with its global ID. Columns show the key data, entity type, name, materials, main dimensions, etc. This makes reviews and checks faster, supports QTO, and lets you link model data to Power BI or project dashboards without extra plugins and softwares. In short, it's light but powerful way to turn IFC models into clear, usable data, saving time and making your BIM work more efficient. Automation in NHN, Nathan. Let me introduce Nathan, a free open source automation tool. You don't need to code, just drag and drop blocks like in Dynamo or Grasshopper. It's zero coding. It connects more than 500 applications, Google Calendar, Microsoft Teams, OneDrive, and so more. It can send emails, move files, call APIs, and add AI steps. You can run it on your laptop or your own server, so you keep control of your data and customize it. In AEC industry, common uses are QTO reports, syncing model data to dashboards, and automating model checks. Example, when a new IFC file appears in folder, Nathan converts it to Excel. uploads it to SharePoint, and posts a Teams message with the link. We haven't used it on this project, on this study project, but it has strong potential to automate QTO, reporting, coordination, and to cut manual work. Augmented reality helps AEC teams see designs at full scale and make faster decisions. For this project, we used IFC-XR to run quick immersive reviews. The workflow is simple: export and IFC uploads and open AR. In minutes, we can find spatial conflicts. We capture screenshots and short notes and share them with the team. The result: few misunderstandings and clear decisions for clients. In other innovations, it's Trimble AR brings to the model to the fields. We load the model from Trimble Connects, align it to site control markers, and see precise overlay on the real environment. Teams verify layouts, slab edges, openings, and embed locations before installations. If something does not match, they flag it on the spot with a photo and comment, then sync back to the office. This reduces errors, RFIs, and rework, and improves communication between field and design teams. For complex projects, Trimble AR helps check progress in real time and make confident data-based decisions.
Carbon emission. There are many innovations in the industry to help us with different aspects. Among them, carbon emission estimation solutions help us design and build more sustainably. For example, the LCA plugin uses AI to quickly generate carbon footprint values during the design stage, making it suitable for early comparison and decision making when exploring different design options. It provides fast, data-driven way to estimate emission and evaluate alternatives. On the other hand, ORIS plugin, more focused on construction phase. It calculates emission based on real material suppliers like asphalt or concrete plant and their distances from the project site. This allows more precise results, factoring in transportation and actual supply chain. Both plugins receive the geometry features from the model and have the ability to insert back the estimated carbon emission quantities into the model geometry. Together, LCA and ORIS provide a full picture approach. LCA supports early design choices, while ORIS refines the calculations for execution, helping us minimizing carbon impact across the project lifecycle. Site management. In construction phase, platforms like Leica Connex play a crucial role in integration and controlling heavy machineries and earthworks. By connecting excavators, graders, and other equipment directly to the digital model, Connex allows real-time tracking of machine positions, tasks, and progresses. Operators receive precise design data in their cabs, which improves accuracy and reduces the need for manual staking. For project managers, the platform provides a live overview of productivity, material movement, and compliance with design tolerances. This not only minimizes rework and waste, but also supports better decision-making and coordination across the site. In short, Leica Connex creates a direct link between the digital model and physical construction, ensuring greater efficiency, cost saving, and quality in earthwork operations. 4D simulation. 4D simulation adds significant value during the construction phase. One of the key benefits comes from assigning detailed attributes to the every model elements. These attributes allow elements to be automatically matched to the corresponding task to the construction schedule, which saves time, reduces risks of human error, and ensure consistency across the project. By linking 3D model with the project timeline, 4D simulation gives us a dynamic view of how construction will progress. It helps us identify clashes in sequencing, anticipate resources, and optimize the site logistic. Team can clearly see when and where activities will occur, which improves coordination and communication between stakeholders. Overall, 4D simulation enhances predictability, reduces delay, and provides a transparent roadmap for the construction process. This not only supports more efficient planning and execution, but also build the confidence that the project will be delivered on time with fewer risk. 5D. In 5D modeling, cost data is integrated directly in the 3D model. By assigning codes like CES or ICMS to each element, quantity can be automatically extracted and linked to the pricing database or cost estimated tools. This eliminates repetitive manual takeoffs, ensures accuracy, and allows instant updates whenever design change occurs. We assign cost codes to each model element, so it directly links design with cost. The geometry provides quantities like length, area, or volume, and the cost code connects those quantities to a unit rate in the cost database. For example, a concrete wall modeled in 3D carries its cost code, which pulls the right rate and calculates total cost automatically in 4D software platform. When the model changes, quantities and cost updates instantly. This creates a live accurate cost plan and ties design, schedule, and budget together. Overall, 5D BIM supports better decision making, reduces financial risk, improves efficiency by integrating design, time, and cost into one streamed workflow. Asset management. BIM plays a vital role in asset management by providing a digital twin of facility that stores accurate, up-to-date information about components. It works by integrating data from design, construction, and operation to one connected model. Sensors, IoT devices, and maintenance system feed real-time data into a twin, so manager can monitor performances, predict failure, and optimize the cost lifecycle. Thanks for listening, and we hope that you enjoyed it and got some fresh ideas about BIM. Thank you, everyone.
Thank you. Thank you so much. Let's move on to the Q&A session. Let me try to share my screen again. And let's see the questions. I saw one question from Wendy that she asked, she told, excellent presentation, guys. Did you perhaps get the chance to create a digital twin for your project? And which software did you use?
I think maybe Dmitrii want to take on this, take over this question.
Yes, I've researched this process. So we don't have much time for develop digital twin, but if you want to do it, and if you have time, you can do it in application from Bentley, iTwin name, yeah, iTwin. I've did it with demo models if you won't do it, you need programming skills, and you can implement it with your model. But for implement your study projects, you should get enterprise access for IT. So
Great, Dmitrii. Thank you. Thank you. And I saw another question here. All of this workflow will be learned in details and practical during the masters, or it will be just presented as in this webinar? Can you explain a little bit for Mohammed, please?
Okay, I can take on this this question. In the master, we had some teachings about the overall of the processes, how are the concepts of them, and what are the points that we have to take care of. But it's a master, and it's a practical master. You have to be a little bit proactive yourself. And many of these solutions, we went after them ourselves. We found them ourselves. We put them in trial ourselves. Some of them were introduced to us by ZIGURAT, but a part of them we went after them to enrich our project. So it is a little bit of both, but it wouldn't hurt. The thing is that if you listen to the part that I talked about, risk management is the thing that when you work with BIM, the solutions in the market, they are changing and mushrooming every day, every hour. This master, we made it a couple of months ago. I believe that today there are more solutions in the market. So the risk management tells us we have to go after opportunities to maximize the greater success rather than just using the conventional methods. So I think it depends on you and how proactive you are.
Great. Thank you, Chakad. And sorry. Today is it's really difficult for me to speak in English. I'm sorry. I'm Brazilian, I'm here in Barcelona, so it's a lot of language in my head. So this question is for both of you, okay? What's one thing you learned in the masters that really stuck with you or made a difference in your day-to-day work?
Dmitrii, want to go ahead?
I think the main from this masters, I've studied how to manage. That's how to manage people. It is necessary, and how to solve risks. So every day of the previous masters, I've studied each day from my teammates, from Chakad, and it's necessary planning before start projects. So right now I'm BIM manager, and every project I've invested time for planning. It's half of the future success. And the next point, I think, is that people, it's necessary. So I know that ZIGURAT divided you by different teams, and your teammates is necessary. If you have your similar goals, you will get this, and you will develop interesting and great projects. So I think people is necessary too. So
if I want to add to it, yeah, a part of it, the thing that I wanted to tell, Dmitrii already told about planning. Yeah, always plan before you act. I strongly suggest you to make process maps for yourself before you move on and involve yourself in a process. But beside it, I always tell 3 words: requirement, requirement, requirement. Gather your requirement. Before you do anything, gather your requirements.
Perfect, guys. Thank you so much. And do you want to leave a message to our audience and we finish the session? Could be like a phrase or thank you so much, bye bye. What do you want to tell to people that are seeing now and that will receive the recording, because this session it's being recording, so everyone will receive the recording on their email. So feel free to leave a message, please.
Yeah, I recommend people arrange meeting per 3 or 4 weeks per week. It is necessary. I think it's our strong skills with Chakad. We push each other each time, and I think it's necessary for the team. So see your deadline and optimize your work if you have time. So, and every task that ZIGURAT send you, please do it more than ZIGURAT ask you. It's necessary, and result will be brilliant.
Very good. From my side, I would recommend everyone to never ever stop scanning the market. Solutions are out there every day, new solutions. So if you stop scanning and stop educating yourself, you will be outdated in 1 week or in 2 months. And besides that, Dmitrii and me, we are both enthusiastic about BIM. You can find us on LinkedIn, and we would be glad every time you contacted us and we could have a chat about a BIM subject or whatever subject that you would love to. And thank you for listening to us.
Thank you.
So a big thank you to Dmitrii and Chakad for such an inspiring presentation. And of course, thank you all for being with us today. Your presence makes all the difference. And stay tuned for our upcoming events and opportunities. Until next time, stay curious, stay connected, and take care. Thank you. Bye-bye.